Do you know what radioactivity is? It has to do with instability in an atom's nucleus. Have you ever pushed magnets together of the same polarity? They repel, right? Believe it or not, this is exactly what is happening inside the nucleus of a radioactive atom. Inside the nucleus, we have protons and neutrons. Protons are positively charged, okay? You probably knew that. Like those magnets, they hate being next to each other. The electromagnetic force is constantly trying to push them apart. So why doesn't the atom explode? Well, nuclear force. Okay, this is the glue provided largely by the neutrons, which are neutral in force, that overpowers the repulsion and holds the nucleus together. Nuclear force is extremely powerful. But the balance of this, it has to be perfect. Sometimes the balance is perfect because there's an even amount of protons and neutrons. Take carbon-12, for example, okay? 6 protons, 6 neutrons. Or sometimes the balance is perfect because there's just the right amount of excess neutrons in the nucleus. Like gold-197, for example, which has 79 protons and 118 neutrons. The term for when there's a different number of neutrons than protons in a nucleus of an atom is called an isotope. If an atom has too many or too few neutrons, the glue is unstable and the nucleus decays. Alpha decay is when a very large nucleus sheds alpha particles in the form of helium nuclei, 2 protons, 2 neutrons, changing the identity of the atom. Imagine a nucleus that is just too big and bloated. It needs to lose mass fast to become stable. That's alpha decay. Beta decay is when a nuclei fixes its particle ratio, which also changes the identity of the atom. Example, carbon-14 has 6 protons and 8 neutrons. The beta decay process turns 1 neutron into a proton, making nitrogen-14 with 7 protons and 7 neutrons. Carbon-10 has 6 protons and 4 neutrons. The beta decay process turns 1 proton into a neutron, making boron-10 with 5 protons and 5 neutrons. Gamma decay is the most energetic of the decays. It's also very dangerous. It doesn't change the identity of the atom because particles do not change. Only excess nuclear energy is shed through gamma energy. Think of a ball bouncing up and down. Think of the nucleus and it just settling, and getting rid of that energy. Gamma decay is the reason the area of Chernobyl is still rather toxic today. So once again, what is radioactivity? It has to do with an unstable nucleus that is trying to stabilize and it releases energy in the process. And I hope you found this.